One of the most important relationships between different animal species is predation. The predator-prey interaction, in which a predator eats a prey. Predator species have several adaptations that help them catch prey species. Prey species have adaptations too, physical and behavioral adaptations that enable them to elude prey and avoid being eaten. These defensive adaptations evolved in prey species through repeated encounters with predators over evolutionary time. Some animal defenses are passive, such as hiding. Some defenses are active, such as escaping. Fleeing or running away is the most direct anti-predator response, but requires the animal to expend a lot of energy. The rabbit uses a lot of energy running away from a lynx. Many animals avoid too much energy by escaping into shelter. Several prey species have some sort of vocalization and alarm call to announce the presence of the predator. The alarm call often triggers a behavioral defense called mobbing. During mobbing, if the prey turns the table and attacks the predator, for example, when the chickadee spots a threat, say, "I know," it calls out the alarm. The chickadee starts scolding the other, sometimes actually striking it from behind. But when biscuit and who participate in mobbing, they chase down Sarajao, usually vocally loudly. Their intent is to move on a natural area. So animals rely on defensive coloration. A well-known example of defensive coloration is camouflage, which makes the prey difficult to spot against a background of similar color. All a colored animal has to do remain still to avoid being seen. Thus, camouflage is probably the most effective passive defense. Incidentally, some predators also use camouflage, especially predators who lie in wait for prey and blend into their environment. Most the camouflage themselves too much leave stand a good chance of not being seen by moth-eating birds, unless, of course, the moth becomes so popular that a bus is likely to accent. Once the bird learns the moth's identity, it has a search image for it. The moth disguise is useless. Looking like a leaf is an advantage because the birds stand and hope they are moths, and it frequently, as long as sufficient number do turn out to be moths. Another animal defense is the use of chemical weapons. We are all familiar with the chemical weapon of the skunk. Some animals, like poisonous toads and frogs, can synthesize toxins that attack the nervous system of predators. As animals acquire chemical defense passively. For example, some caterpillars acquire poison from the plants they eat. Then, when we bite a caterpillar, the bird quickly vomits. After that, the bird will avoid eating that kind of caterpillar. Some birds can remember bad tasting meals a year later. Another defense adaptation is warning coloration. Animals with effective chemical defense are often brightly colored, and there is evidence that predators are more cautious in dealing with bright color patterns in potential prey. This is probably because a lot of poisonous or bad-tasting animals are colored brightly, with black and yellow or black and red stripes. Warning coloration clearly trains predators to avoid eating these brightly colored animals. Some birds have an instinctive tendency to avoid warning coloration. For example, young warblers leave wasps alone because the birds recognize the danger in the black and yellow stripe of the wasp. However, warning coloration is not absolutely defense, as they are only showing that many occasional feed on bees and wasps will help them to learning to cope with their chemical defenses.